Hello, guys. Am I audible?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. Okay. Okay, great. So, before just going ahead, I just need to just for the group one, I guess you people are done with the presentation yesterday. So, guys, sorry for this, but you need to just again present the screen and show me the like the GitHub of yours where you have uploaded the week-wise mini project till group till week 5. That is first, second, third, fourth, fifth week till 5 weeks, whatever be the GitHub details that you have taken, uploaded the project, that details I need to see it once, and also the mail where you have just shared it. So you need to check, like share me those again. So you can just share your screen and just based on that, show me that once again. So I'm just calling out the name, guys. Please just show me the like share your screen and show me the details. So it's Aditi. Aditi, you are here. Can you just show
Yes,
me?
ma'am. Yes,
Yeah.
ma'am.
Other
Can you hear
guys,
me?
can you please switch off your mic? Yeah, Aditi, it is visible. Yeah,
Yeah,
just
ma'am.
a moment.
So, we'll go with the first project on my GitHub.
Okay.
Here I
Okay.
have mentioned the collab file, then
Mm-hmm.
readme, then data 1,
Right.
data 2, data results, and main py.
Fine.
Should I go open this too?
No, you don't have to. That's fine. This is
Okay.
project one, right? The
Yes.
first week project. Okay. Then second week project, please.
Second week, I have just uploaded the collab file, readme, and requirements.
That's fine.
Yeah. The third week was fashion image clustering. So
Okay.
I have uploaded the collab file and readme.
Okay.
Yeah, ma'am. And the fourth week was career path clustering. Here I have mentioned the collab file, readme file, and the resume.cs, means it is the data which I have been
Mm-hmm.
taken from Kaggle.
Okay.
And fifth week project, it was Parkinson's disease project. So I have the readme file, the Parkinson's data, and the collab file. Actually, I was having
Okay.
problem to
Fine.
upload the collab
Got
file,
it.
so I have uploaded it in Python.
Okay, fine. Not
Yeah,
an
ma'am.
issue. Uh, you can you just share me the mail where you have
Yes,
just
ma'am. Yes,
mailed
yes.
the details?
First week project.
Okay.
Yesterday I shown ma'am this in detail.
Yeah, yeah, right. That's why I told today. I also need to see it once. That's why I just
Okay,
told that
ma'am. No
I
worries,
need to
no
see it
worries.
once again.
Yeah, in mail I have just uploaded my data, means my topic
Mm-hmm.
introduction, and here is the collab link.
Okay, okay, got it.
GitHub
Fine.
link I have put it here.
Okay,
So the second week project, I have again mentioned the details of my project. Here the collab file and here the GitHub file.
okay,
The third week project, I have mentioned in very short the GitHub file and the collab link.
okay,
The fourth week project, here in this format, I have just drafted the mail, the GitHub link and the collab link.
okay,
The fifth week project, again the drafted mail, the GitHub repository and a collab file.
okay, okay. Just a moment, Aditi. Just a moment. I just need to just like fill the form related that you have already
Okay,
submitted.
ma'am,
So
no
just a
worries.
moment, please. Okay. Yes, someone's mic is on, I guess. Okay. Okay, Aditi. Thanks for this. You can just stop your screen sharing. And I
Okay,
just have
ma'am.
a question. Like for all of the 5 weeks,
Yes,
you
ma'am.
have just presented your project in the session itself, right?
Yes, ma'am. Yes, yes.
So you don't have any recorded version of it, right?
Yes, ma'am.
Okay, okay. Fair enough. Okay, fine.
Thank you, ma'am.
Thank you. Yeah.
And ma'am, actually, I was having a doubt related submitting the final major project. It is like
Okay.
all the five group members need to mail or any one of these should mail.
Okay, I need to clarify that as well because I don't have the idea on that. So I'll just check once. I guess maybe everyone needs to mail that. So I'll just check it once and will confirm you. Okay, just allow me some time. By the end of the
Yeah,
session,
ma'am.
I'll try to confirm you.
Okay, ma'am. Thank you.
Fine? Okay. Okay. So next is Disha. Disha, you're here. Disha from Group One, you're here. Aditi, Aditi, can you just inform Disha because her details also I need. So if she can respond,
Yeah, ma'am. Currently, she is not meeting. I guess she is in her work. I will just let you know after some time. Disha
fine,
and
fine.
Aryan
Okay.
are currently not in the meeting because they are outside.
Okay, fine. Got it.
Yeah, ma'am.
Okay, not me. Yeah, Priyanshu, Priyanshu, just a minute. Can you just come up on like the? Can you just unmute yourself?
Yes, ma'am.
Yeah, Priyanshu, I have a question. Like you have yesterday, you have shown me that you have shared all of the five like all of the 5 week project in the mail ID, right?
Yes, ma'am.
Yeah. So now I just wanted to ask, have you just shared like did you have presented all of the five project presentation in the session, or you have any of the
Yes, ma'am.
recordings done
Mm, Ma'am, I present in the session meeting.
all the five projects, right?
Yes, ma'am. Yes, ma'am.
Okay, okay, fine. That's the query, Priyanshu. Can you just show me the GitHub link once, the repository of all of the project that you have taken into account?
Yeah. Is my screen visible?
Just a moment, Priyanshu. Yeah, it is visible.
Yeah.
Are you using phone?
Yes, ma'am. Ma'am, I am out
Okay,
of station right now. Ma'am, these
fine,
are
fine.
my
Okay,
repo. Like
okay.
one.
Okay, the one with a project and GNPCI, these are actually your project for the all 6 weeks, right?
Yes, ma'am.
Okay, okay, Priyanshu. And can you just show me the mail once again, where you have just shared the details?
Yes, ma'am. These are the mails.
Okay, just a moment.
Yes, ma'am.
Fine. Okay, okay, Priyanshu. Thank you so much. You can just you can just stop sharing. That's fine.
Okay.
Okay.
Thank you, ma'am.
Next. Okay. Himanshu, you're here.
Yes, ma'am.
Okay. So you are telling yesterday that you are left with sharing one file, I guess one project file along with the details. So I just wanted to ask, like, have you shared?
Yes, ma'am. This is week five because I submit the big five project on the form, not the email. But I yesterday I submit the on the mail.
Okay. 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 Got it. So based on that, Himanshu, you also have shared like the presented all of the five projects in the
Y-
session itself, right?
Yes, ma'am. Yes, ma'am. presented the all
Sorry,
in
you.
session.
Okay, okay, got it. Okay. Just show me your GitHub ones and the mail ID ones, like where you have just shared the
Okay,
mail.
okay,
Just I need
okay,
to
ma'am.
check.
Okay, ma'am. Screen is visual, ma'am.
Just a moment. Yes, it is possible.
So, ma'am, this is my first week project. Open that.
No, it's fine.
This is week second project, ma'am. In this project, yesterday saw the JavaScript, but I didn't get why this happened. So I create a new
Okay.
repo and again upload the file. So this is
Okay.
so
So
any
all
problem?
five projects. No, it's fine. It's okay. So all five projects has been uploaded in GitHub, right?
Okay, ma'am. Yes, ma'am.
You have uploaded. I am questioning you.
Yes, ma'am.
This
Yes.
is a question, right?
Okay, ma'am. I some
No, no. I am just asking you the question. Have you uploaded?
yes, ma'am.
Like all five is uploaded in GitHub, right? I am asking
Yes,
you the question.
yes, ma'am. If you don't understand, so I saw this.
No, no, no. I understood. I am just cross-checking that all five is uploaded, right?
Yes, ma'am. This
Fine,
is
great.
this is week one. This is week three. This is week two. This is week four, and this is week five.
Fine. Okay, Himanshu. You just show me the mail once again where you have just dropped them
O-
the mail that
Okay,
all of
ma'am.
the details, like all of the project details you have shared.
Okay, ma'am. Okay. Once 1 minute.
Yeah, okay.
Uh, this is one. This is week one, ma'am.
Sorry, I can't see it. Just a minute. Yeah, yeah.
Week one. This is GitHub link.
Uh, okay. You just
Uh,
show me like, okay, can you just zoom it out a bit so that I can see it in a single frame? Zoom out.
okay, ma'am. No, ma'am. It is
Yeah.
okay,
Okay, fine. I
ma'am.
understood. 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 Okay. So all five you have shared, right?
Yes, ma'am. This week one.
Okay, fine.
Uh, uh,
Hmm.
so, ma'am, I update the week two project, so I submit again and here mention the issue.
Okay, got it.
So this is week three, week four, and week
Hmm.
five.
Okay, fine. Okay, Himanshu. Okay. Thank you.
So, so I can stop sharing, ma'am.
Sorry, I just, yeah, yeah, you can
Uh,
definitely stop sharing your screen. It's fine. Thank you.
Thank you, ma'am.
Yeah. Okay. So Aditi, are they back? Anything, any details you got? The other two
Yeah,
team
ma'am.
members of yours?
Actually, Aryan is on his way to home. He will be at home within 5 to 10
Okay.
minutes, and Disha is having her dinner right now. I mean, she is busy in something. So, ma'am, I will let you know after some time. You can continue further.
Hello,
Okay, okay, got it.
Yeah,
ma'am.
yeah, ma'am. She is there.
Yeah.
Ma'am, I joined right now. Can you give me 2 minutes? I will open my GitHub and mail.
Okay, fine, fine. Wait, Disha, you can wait. You can take your time. 5 minutes, I am giving it to you. You can do whatever the things are, and then show me. By the time, if Lakshya is here, he can show me. Lakshya, you are here.
Yes, ma'am.
Yeah. Have you just mailed them the details and taken it down in the GitHub?
And I will do it today. I am it.
Lakshya, it's since your team, like your group, has already done with the presentation. So the some of the formalities that you need to do, you have already done with the do. That is the very basic thing that you need to do. So for you, the other people of your team is also getting delayed for this stuff, right? So you need to understand this and you need to do it. Try and do it by today. Fine. I guess you're having the mail ID, right? Where
Yes,
you
ma'am.
need to submit the details. So you
Yes,
have to, and I guess you have not presented any of the project in the session. Have you?
no, ma'am.
Okay. Then for you in the mail, like in the mail where you have to drop the details in the single mail, just go ahead, write week one along with the first week title of the project that you have taken into consideration. Then the collab file link, then along with that the GitHub link, and also the video, the presentation video that you have created and uploaded in the Google Drive. That link you have to paste it for all the six, like five project actually. Okay, and share, and along with that, just go ahead and upload all the five projects in the GitHub.
Okay,
Is
ma'am.
it clear, Laksha? Try and make it by today, only today or tomorrow first half, because tomorrow I'll be seeing for the last time, because I need to give the reference that this week, like for your group, all of the students are done with this task, right? So try and complete it.
I will do it.
Okay, okay, uh, fine. So Disha, you're here.
Yes, ma'am.
Yeah, can you just show me, please?
Yes, ma'am.
Okay, this is week 4 and week 3, right? So what about the other one, Disha? You're muted, Disha.
Hello. Yes,
Yeah,
ma'am. I have shared week 1, week 2, week 5 together and
okay,
week 3 and week 4 individually.
okay, got it. And the GitHub once again, please.
My GitHub is not loading actually. I don't know what is the issue.
Okay, okay, fine. You take your time by the end of the session. If it is possible, then just show me. Fine.
Yes, ma'am.
Okay, fine. Okay. So, group 2, you can just stop sharing, Disha. So, group 2, you are here.
Yes, ma'am. Yes,
Okay.
ma'am.
So, you can just start off with your presentation.
Okay, ma'am. I'm sharing.
Okay, definitely.
Ma'am, is it visible?
Yes, it is visible.
Hi, everyone. I'm Manthan, and this is my team, Fida, Isha, Nishchita, and Hasini. I would like to present our project on advanced predictive healthcare analytics titled as MedSynth, where our core challenge was to accurately identify patients at high risk of developing multiple chronic conditions, also known as multimorbidity. And this is crucial for early intervention and efficient resource allocation and improved patient outcomes. And here is the project summary. This project builds an end-to-end machine learning algorithm where we use synthetic health data to predict risk of multimorbidity, and objectives are like predict the risk of multimorbidity using synthetic patient data, improving prediction accuracy, and supporting better healthcare decisions. And the business context, here we are going to enhance healthcare analytics by using synthetic data generation to make models more robust, scalable, and useful in complex clinical environments. And we have taken the data from Kaggle. It consists of 11 CSV files. All are explicitly on different aspects like demographics, like age, gender, race, ethnicity, clinical history aspects like number of condition, medications, procedures, healthcare utilizations like counter frequency, total claim amount, and temporal data and dates like birth date, encounter dates, condition, onset resolution, and death rates uh, as this. A data processing part we have done like data collection, cleaning, and feature engineering. These all parts will be explained in the later part in brief. And these are the techniques we have used here, like univariate, bivariate, multivariate. Univariate is nothing but using a single dimensions like distribution of claims, ages, condition, and medication as such. And bivariate analysis, we use two aspects: age versus total claims, number of conditions versus number of medications, like this. And multivariate analysis, we are going to use correlation heat map, paralysis, categories plot, and cluster analysis. And the fourth, we are using hypothesis testing. We are using chi-square test, testments, and Man-Whitney testings. Trend and pattern analysis, we use age group versus multi-morbidity. Age age factor is the main thing which uh, age is the main factor which is showing multi-morbidity. And predictive modeling, we are going to use supervised classification and synthetic data generation with CTGAN, counter-tabular generative adversarial networks, and problems addressed, imbalanced dataset with far fewer multimorbid cases. And deployment, we have used Streamlit. And here we are going to import the necessary libraries like pandas, numpy, seaborn, matplotlib as such. After importing all this into the collab, and we are here we can see the total number of patients, conditions, and claims. And dictionary dataset, these are the 11 extinct datasets we are using, like patient, allergies, care plans, claims, conditions, encounters, etc. And comprehensive data overview. In this cell, we are going to uh, define a define to provide a quick summary of each data frame for each file. Uh, Here we are going to show shape, column, data types, and missing values for every data set we are using. Here we can see the overview of patients. It consists of 1462 rows and 17 columns. Here are the column names like patient, birth rate, death rate, etc. And the missing values, missing value and missing percentage also we can see here. It is repetitive for all the 11 files we are using. Here we are going to standardize the column names. Standardize column names, a function clean column is applied to every data frame. It performs the following actions on column names. It removes leading or trailing spaces. It renames the if we see example, it renames the patient column to patient ID for clarity and consistency. And if we want to know why this is done, this creates a uniform naming convention, which is crucial for preventing errors when merging the tables later in the part. And converting dates is for necessary to perform accurate date-based calculation, most importantly for calculating patient age. And patient age is the thing which determines whether you have multimorbidity or not. In this part, we are going to handle missing values. We are going to use a simple method where if any value is missed in the numerical part, then we are going to insert 0, and if there is anything missed in the text columns, then we are going to insert unknown. So by this way, we are going to quickly and effectively ensure the data is complete and ready for aggregation and modeling, which cannot handle missing values. In the next part, we are going to aggregating the patient data using feature engineering. This transforms multiple complex tables into a concise set of patient-level features. Instead of tracking every single claim, we now have a single number presenting the total claims for each patient, making the data much easier to model. After all this cleaning is done, then we are going to merge into final dataset, and this can be called as master dataset. And this master dataset consolidates all demographic and aggregated clinical data into a single analysis ready table where each row corresponds to one patient. Adding age column is the next part. This is done because age is a powerful predictor of health outcomes and is essential for multimorbidity risk model. Encode categorical columns. This is done for the purpose of transferring the data into a purely numerical format that can be fed into machine learning algorithms. As we all know, if we fed the data in numerical form, then it will be easy for CT-GAN model to take the data. And here the final check is going on. Finally, the code prints the shape of DF final data frame to confirm its size and display the mapping for the encoded columns to ensure the new numerical values are understandable. Here we are going to see whether the data is understandable or not. In the ninth part, we are going to export dataset. The final and cleaned data form is saved as cleaned dataset, and the code to do this is commented out. It would allow this process dataset to be easily used in other analysis or notebooks without repeating the processing steps. Next, it will be continued by Hasini.
Yes. Now we'll get into the outlier detection and the treatment. Firstly, we'll have a brief description about the outliers. Actually, the outliers have been caused by the measurement errors and the experimental errors that are present within the data.
Manthan, you need to share the screen,
And
right?
nope, I will share, ma'am. I'll share it.
Okay.
Is it visible, ma'am?
Yeah, it is visible.
Okay, ma'am. Here we'll be getting into the outlier detection and the treatment, where previously we have loaded the data set that will be copied as the scale data set for the outlier treatment, and we will be performing on outlier treatment on the numerical columns. So we have considered that numerical columns over here, and on the numerical columns, we'll be performing a technique called capping, which is formed by calculating the IQR value, which means the interquartile range. Here, Q1 and Q3 are the bounds of the columns, wherein the Q1 is the lower bound, which is of 0.25 value, and Q3 is the upper bound, which is 0.75 value. And based on that, here lower bound and upper bound values are calculated over here. And these are being represented as data frame outliers for the capping values. And here, at last, it's been printed as outlier treatment completed using the IQR capping technique. Here, we'll be visualizing before and after capping plots for easier depiction for us. Here, we have considered this box plot technique for before outlier treatment. We have considered the Indian red color, and after outlier treatment is for sea green color. Here, we'll be considering the features like age. Age is one feature, and before and after the outlier treatment, it there is no major change on that. Let's get in. Let's go for the total claims. Total claims has a major part of the outliers in the data where we can observe over here on a higher count. There we can represent the claim outliers over here, and after the outlier treatment, we have green color showing without any outliers present in the plot. And coming to the number of conditions, like the health conditions a patient have, here there are only a fewer outliers before the outlier treatment, and after the outlier treatment, the count is negligible. And here the number of medications a patient is taking on. Before the outlier treatment, the value is around 10 to 20 and a few for the 80 count. And after the outlier treatment, the outliers have been permanently removed for the medications feature. Next is the missing values heat map. We'll be getting the missing values representation in the form of a heat map over here. Here on the x-axis, we can see the n number of features over here, like the patient ID, birth date, death date, SSN, and rest all till the age. Here we can see a single color, like the yellow part for the death date feature, which means death date feature has a more number of missing values. And next comes coming to the EDA part. Here we have imported the necessary libraries for that using Plotly Express and Matplotlib and Seaborn. First, we'll be depicting the birth year distribution of the patient. We have considered the year of birth and count part using the hist plot. On the x-axis, we have the birth year from 1920 to 2020. On the y-axis, we have the count, which of the number of patients. The highest number of births occurred in the year 1960. We have choose this plot as we can understand the continuous distribution of the birth years and revealing the demographics of a patient. And over here, the insight we can cover is the age groups are performed with peaks in both the older age and the younger patients also. And next, we'll be depicting the patient age distribution using the histogram. Here we can observe the age over here. First, the age of patients from 5 to 9 years are of 53, and the major part of patients are in the age of 60 to 64 with a count of 88. Here, the distribution will be showing a age range of 0 to 100 with concentrations of middle-aged patients. And next is the gender distribution. We have depicted with the help of bar graph. The gender distribution have been considered based on 2 points, wherein the gender equals to 0 is being depicted for male in the blue color, and gender equals to 1 is for female with yellow color. Here we can see these are of a balanced count, approximately equal count. For the male, we have 721 patients, and for the female, we have 741. Next is the race distribution. Here in the data set, we have various race with a count of 0 to 3, like Asian is for 0, like 0.5, and black is for 1, Hispanic is for 2, and white is for 3. With a count, the minimal number of patients are for race 0.5, which is Asian race, and highest is for the race 3, which means the white, at a count of 1085. Here, the race category of white, are dominating the data set, and others are sparsely represented over here. And this need careful augmentation later part. Here we'll be seeing the ethnicity versus gender. Ethnicity is nothing but the African, American, like different ranges over here with their values, labeling over here. And we can see the sunburst depiction over here with the values. And the inner circle will be representing the ethnicity values like 10, 11, 6, and 15 with the different color codings. And for each color coding, like the each ethnicity value, we have 0 and 1 for the genders, like male and female. For example, let's consider the ethnicity value of 10. For male, we have at a count of 740 conditions, and for female, we have 683 conditions. Like that, this depiction has been done. And even this ethnicity and the gender groups will be contributing most to the multi-morbidity cases. And next is the top 10 most common conditions. We'll be considering the bar graph over here. On the right hand side, we can observe the number of conditions listed over here, like viral sinusitis, acute viral pharyngitis, bronchitis, pre-diabetes, and etc. Here, each condition has been depicted with each color visually. Firstly, this visualization is not useful for the modeling purpose, but it is useful for the healthcare professionals to easily analyze which condition has been treated uh, importantly. Here, the patient's count is huge on condition for viral sinusitis with a count of 1,125. Next, top two is the acute viral pharyngitis with a count of 602 and acute bronchitis for 508. The least condition count is for sprain of ankle. So the top three conditions indicates the acute respiratory issues a patient is suffering with. This must be prioritized in the healthcare resource planning also. Next is the claims cost distribution using box plot. Here the total claims is nothing but the total amount paid by a patient for the hospital bills. Here the Here it is box plot is represented through a technique called IQR, which is interquartile range. The median count is 1200, and lowest bound is 400, and the highest bound is 1800. The maximum count is depicted as 3900. So this highlights the moderate variability in the patient cost, identifies the extreme high cost for the targeted analysis. Next is the conditions per patient depicted using the histogram over here. And the number of conditions are ranged from 0 to 12 over here. The highest conditions per patient with three conditions, where the highest part suffering for a patient is more than two, which means 239 patients have around the multimorbidity cases. Yeah, the insight has been listed over here in the same way. Most patients have 2 to 5 conditions, peaking at 3 conditions as maximum, with high multimorbidity cases like 8 plus conditions are for minimal count of patients, and the least count is 12 for more 12 number of conditions, which is also a highest multimorbidity case. Most common allergies. Uh, we are depicted using the bar plot over here. Here on the right side, we can observe the allergy type for mold, dander, house dust mite, grass pollen, tree pollen, shellfish allergy, bee venom, fish, peanuts, and nut. This is ideal for enabling the categorical data, which shows the prevalence of each allergy type clearly. The highest count for allergy is with patient having mold allergy to mold. And the insight we can found out is the top three allergies, like which are allergy to mold, allergy for dander, and allergy for house dust mite, are at a higher range, which we can observe over here clearly. And this highlights the common environmental issues we can see in the most of the population over here, which requires a focus on the allergy management strategies. And next is the distribution of medical conditions per patient. Um, and we have used a histogram over here for depicting. And we have performed histogram visualization by calculating a mean line on the feature of number of conditions. And we will be adding a thin line in the visualization, as you can see here. The red thick line depicts the mean value, which is of 4.8. And on the right side, on the left side, we will be having the count of number of patients having the medical condition per patient. And this is the average patient has around 4.5 sorry, 4.8 conditions, and the multi-morbid patients which who have more than medical conditions are at a range of 89.2 percentage. And the insight we have seen over here is average multi-morbidity of 4.8 conditions, with most patients clustered around 3 to 6 conditions, which reveals the moderate disease burden on the patient. And the rest of the EDA plots will be carried out by Nishchita.
Ma'am, is my screen is visible?
Yes, it is visible.
Okay. The next plot is about number of medications per patient. Here, this graph shows how many medications each patient has been prescribed. Most patients have a moderate number of medicines, while a few have very high counts. This indicates patients with chronic conditions who require multiple treatments. And next is encounters versus conditions. These plots compare the number of hospitals encounters with the number of conditions. As the number of conditions increases, the number of encounters also tends to rise. This shows that patients with more health issue visits hospitals more frequently. Next plot is about claims versus age. Here, this plot shows the total medical claims made across different age groups. We can see that middle-aged and early patients tend to make more claims than younger ones, which is expected since older people often need more medical care. Next, age versus conditions. This chart shows how the number of conditions varies with age. Generally, as age increases, the number of diagnosed conditions also increases. It highlights that older patients are more prone to multiple health issues. Next, gender versus claims. This visualization compares the number of claims made by male and female. This difference between gender is not too large, showing that have nearly equal healthcare utilization in the dataset. Next, average conditions by race. This plot shows the average number of medical conditions per race. Some racial groups have slightly higher average, which may reflect health disparities. It helps us understand demographic with healthy patterns. Next plot is about conditions versus medications. This plot shows the relationship between the number of conditions and the number of medications. As expected, patients with more conditions are given more medications. This confirms that disease complexity increases medicines requirements. Next, correlation heat map. This correlation heat map helps identify relationship between key numerical features like age, medicines, encounters, and claims. For example, medications and conditions show a large positive correlation, which supports our earlier observation. Next is about parallel categories. These parallel category plots connects multiple variables like conditions, medications, encounters, and claims to show how they interact together. It helps visualize the overall flow of data. For instance, patients with more conditions usually have higher medicine counts, more encounters, and larger claims. Next, key insights from the exploratory data analysis. From, from the VCDA, we can see strong patterns. Patients with more condition take more medications, visit hospital more, and generate higher medical claims. Age also play a big role, with older patients showing higher risk and treatment cost. Next, EDA report and modeling outlook. The EDA provides a strong foundation for our synthetic data generation. It helps us identify which variables are most important to maintain in the CTGAN model, such as age, conditions, and medication patterns. This ensures that the synthetic data resembles real-world patient behavior. Next, model recommendation. For modeling, we recommend using advanced generative models like CTGAN because they can handle mixed data types and capture complex relationships. Further fine tuning can improve the synthetic data quality and reduce bias. Overall, our analysis provides clear insights into patient patterns, hospital encounters, and medical costs. The CTGAN model will help generate realistic synthetic patient data while preserving privacy, making it valuable for research and healthcare analytics. The next slide will continue by uh, next slide is continued by Sidama.
Good evening, all. Good evening, ma'am.
Good evening.
Is my screen visible, ma'am?
Yeah, your screen is visible.
Okay, I will be continuing with the modeling part. So, before we dig into the modeling, let's just summarize part one of our project. So, we collected the data and had a comprehensive data overview, standardized the column names, and we handled missing values, aggregated the features for each patient, and merged all of those aggregated features with the patient table we had. And then encoding and scaling was done on the merged dataset, and did the final check of the merged dataset and saved and downloaded the same as a CSV with the 1462 records and 28 features. We performed outlier detection and treatment. After that, we identified relationships between the clinical demographics and outcome between for features and uncovered patterns that are relevant for prediction. Hence, we set a strong foundation to guide further modeling by exploring the important insights from EDA. This is what was done in part one. So in the modeling, uh, the size of the data set saved was 1462 rows and 28 columns, which are including the engineered columns. Here's challenge is to uh, tackle the class imbalance we have, and we use the approach ctgan to generate synthetic data. We have the problem is binary classification. We have to classify the data points as multimorbid or not, and the class 1 represents multimorbid and class 0 represents non-multimorbid cases. So the summary of the project goes, we'll be performing hypothesis testing on a few features which will show the actual necessity of those, and then modeling will be done using both supervised, unsupervised, and also neural networks. And then will be, since we encounter class imbalance there, we will be balancing the data using synthetic samples generated by synthetic ctgan, and lastly make the model ready for deployment. So let's begin importing the necessary libraries here and loading the cleaned master dataset, which is scaled with the scaled features that was saved. So why we are taking multimorbidity as the challenge here is, since there's the aging population, like people live longer, they tend to develop more health conditions, and we need it for the precautionary measures, and uh, like in case of healthcare providers and the clinicians, when these when the probability they have, when they know the patient is of high risk of multimorbidity or not, they can um, take the decisions of not over prescribing them, or the extra diagnosis is needed or not. So this is why we chose multimorbidity. Coming to hypothesis, hypothesis testing will validate the patterns we have uh, selected that is necessary. Like it should statistically show that they are important in our modeling. So I have taken three hypotheses here. Hypothesis one says patient with more than two conditions have higher mean total claims. So total claims here is the total amount paid, billable amounts by the patient to the hospital. Per patient, it is calculated and saved as total claims in the aggregated features. So, hypothesis one, we have used t-test. It is suitable for checking a difference in means between two independent groups. Here, we used it to compare the mean claims between the multimorbid and non-multimorbid classes, like which mean is higher, and the outcome, the p-value we had lesser than 0.05. So we reject the null hypothesis, that is the mean claims are equal, and we go with the alternate hypothesis, that is class 1, which are multimorbid, have higher claims compared to the non-multimorbid patients. Hypothesis 2 claims that correlation between number of conditions and number of medication. So here for hypothesis 2, we have used the Pearson correlation. So it will determine if there is a linear relationship between number of conditions and the number of medications a patient has. So it will basically measure the strength of correlation using correlation coefficient. Um, Here as well, we can see the p-value is lesser than the alpha value, and which means there is a strong correlation, as the number of chronic conditions increase, patients tend to be prescribed more medicines. So here we reject the null hypothesis and go with the alternate hypothesis again. The third hypothesis is chi-square test we have done, and this is to check the dependency of gender and multimorbidity. So to check whether is gender associated with being multimorbid or not, it applies the counts of patient by gender and multimorbid status. So this as well gives a p-value less than the alpha value, and we fail and we reject the null hypothesis and conclude that gender is indeed associated with the disease burden. So all of the three hypotheses conclude to reject the null hypothesis, and thus hypothesis testing insight gives us that multimorbidity relates to higher claims and higher medications and higher conditions, and also varies by gender. Now we are preparing the data for supervised and unsupervised modeling. Feature selection in data split is done. The numeric features and categorical features are selected. Here we are excluding the number of conditions column from the dataset, because number of condition will it is like a data leakage if we use. Number of condition is the chronic condition a person has, so that will depict the multimorbidity. So we remove that in order to train the model well and avoid data leakage, and we combine the numeric features and categorical features into uh, declaring it as features, and train and test splitting we did. The target here is multimorbid. So now numeric and categorical transformers. Transformers is nothing but we apply the scaling and encoding, and those transformer, the column transformer, it applies to the right columns. So the numeric transformers are applied to the numeric feature, and the categorical transformer are applied to the categorical features present in our dataset. Coming to supervised modeling, we've taken random forest first, because random forest handles mixed data type well. Since we have both numeric and categorical features, we used random forest. Since we have splitted the data, training data into 80 and 20%, 80 for the training and 20 for the test. Accuracy, the overall accuracy we had was around 94%, and also ROC, AUC we had 80%, which is good because the rare class, the discrimination is identified of the rare class. But when we look into precision recall and F1 square of class 0 and 1, class 0, which is non-multimorbid, are trained well. The model is trained well. It is identifying the non-multimorbid records well, since they have higher value here, 96-97%. Whereas when we look into class 1, that is multimorbid, excuse me.
Someone mic is on, I guess. Yeah. Actually, my mic was not opening. I was trying to. You can continue, Feda.
Okay, so the class 1, the precision recall and FN score are have a value very less. There is 75% still missing across, because this is because there is a high class imbalance here. There are 280 samples that are of non-multimorbid and 13 samples. Since it is a rare class we have in the data set, it is only 13 samples, so the model is not training well, is not learning well on the multimorbid cases. So it is under detecting the multimorbid cases because of class imbalance. The model is mostly training on the uh, non-multimorbid patients. So we go to the XGBoost. So XGBoost is mainly designed to handle the complex patterns inside the data. So again, here the accuracy we got is 92%, quite lower than random forest. Random forest has had a 94%, but the ROC the discrimination of the rare class is higher compared to the random forest. Here as well we can see for the class 0 the metrics have higher value. The model is training well on class 0 non multimorbid, and for class 1 it is still missing the data. It's not training well because of the class imbalance we have here. Uh, Next is the dimensionality reduction. Here we need this to show the clear separability between multimorbid and non-multimorbid. By this projection, we can see some of the class 0 and class 1 are overlapping with each other, so that if there is no clear separation, we can say. Mm, so there is a chances of the model misinterpreting class 0 as 1 or vice versa. So by this we can conclude that there is need for advanced modeling, or we can add more features to train the model well. Coming to the unsupervised modeling, here we import the libraries and again split into 80/20 and scale the numeric features. Like we've already scaled the features, but if in case uh, some other data set is uploaded, we need to scale them for a safer side. Computing the class weights. So computing the class weights is necessary because we saw high imbalance in the data. Now when we compute it, class 0 has 0.5 percent, 0.5, and class 1 has 10.8, so which is nearly equal to 20 times that of class 0. Since class 1 is of rare cases, we have very few, 13 samples, the weight is given more to class 1 so as to balance the data and model. So the model mostly focuses on higher weightage class, that is class 1 multimorbid. Now building the neural network. So we've used three dense layers and a total dropout of 50%, and activation, ReLU, and sigmoid. Optimizer was used Adam, and a loss function is a binary cross entropy. We've used early stopping here, which will monitor the validation loss for a patience of 10 epochs, and if the validation loss does not improve by 10 epochs, the uh, the training will stop there, and if it increases the training will go on until it restores the best weight of all the matrices. Like if it encounters the best weight among all, it will stop the epochs and the training so as to avoid overfitting. If we do not add early stopping, even though we had the best weight, the epochs goes on until uh, declared like 100 or 200, and it will overtrain on the training data set we have. So that will result in overfitting. To avoid that, we will be using early stopping. Now training the model with class weights, we had an early stopping, batch size is 16, and 100 epochs we're running here. So we can see the epochs have stopped at 47 out of 100 because it encountered the best weight here for this model, for this data set. But we can see that the validation loss is 46%, accuracy is 80, and validation accuracy is 76, which is not a good model for deployment. And the confusion matrix shows that out of 280 samples of class 0, 103 were misinterpreted as class 1, and among 13 samples, only one were misinterpreted as non-multimorbid. So again, it shows the class imbalance here. For class 0, the precision F1 score and recall are higher, and for class 1 it is low. But due to the class weights we assigned, the recall for class 1 is 92%, and only one of among the 13 samples were misinterpreted. So there is a higher score for recall to the class 1. And the accuracy, like overall accuracy, is 65%, which is not a robust model, we can say. Class 0 accuracy is 63 because many were misinterpreted, and class 1 accuracy has 92% because only one among them was misinterpreted and others were learned well. Plotting the curves, we can see the training and validation loss and accuracy follows the same trend, but the loss stops for 0.4, that is 40%, but we need to decrease it to 0.04 as such, and the accuracy is not up to the mark, it is only until 80%. So we can say the model is not suitable for deployment and needs uh, more training and more data samples. So that's next is the k-means clustering and alternate Gaussian mixture we have used here to see the clusters. This k-means depicts two clusters, and we can say that one is multimorbid and other is non-multimorbid. So that's when we require citigan modeling in order to generate more synthetic and realistic data to train our model more on diverse patterns and handle the class imbalance. So installing the citigan, and for some cases the older version does not work, we have to install the upgraded version as well. Necessary imports, and here we're preparing the data. So from the data set we are splitting the minority class, that is minority class, the rare class we have is multimorbid. So from the data set, multimorbid, where the value is 1, we are taking that and storing it into df minority, and we'll use only the relevant columns among the 28 columns which are necessary. So we split and we prepare the data. Now we'll fit the citigan model. We run 300 epochs and fit with the minority df minority. We took the rare classes and we're generating a sample 200 samples from the citigan of the minority class, the multimorbid class. Now we're augmenting it with the original dataset using the concat function from pandas. The original cleaned data set we had df, and the synthetic minority data set that was generated by citigan, we augment them and shuffle to gain the proper insight. Now splitting the features again into 80-20, test size is 20, scaling the numeric features. These are the numeric features we have among the augmented data. Again, now computing the class weights. When we compare to the previous computation, we can now say the weight has reduced to 3 from 10, even though it is still higher than the class 0, but comparatively to the previous one, the class weight is a bit balanced. Now we have little higher samples of class 1 which were generated from citigan. Now the model can train fairly. Building the model again, neural network. Here we've taken 4 layers of dense. Again, ReLU and sigmoid are the activation function. And same thing, optimizer is Adam optimizer. Binary cost entropy is the loss function. Now training using the early stopping here, 100 epochs and batch size is 16. Class weights, the computed previous one, and the callbacks we used here is early stopping. Since we used early stopping, the epoch stopped at 67 because it restored the best weights overall. We can see the validation loss has got down to 0.04, that is 4%. Accuracy 99%, which is great, and validation accuracy as well 98%, which is great as well. And since it is early stopped, the model is avoiding overfitting and trained accurately. So previous neural network we had an accuracy of around 65 to 70%, but now it has increased from 60 to 90%. We can say the model has learned excellent from the synthetic data as well, and the class imbalance was handled, which was the main challenge we had from the dataset. Evaluating the model, we got the confusion matrix. Among 280, only 6 were misinterpreted by the from the class 0, non-multimorbid. Compared to the last one, we had 103 out of 280 which were misinterpreted. But now the model has learned fairly, and only 6 were misinterpreted. And among class 1, there was no misinterpretation. All 53 of them were classified as multimorbid. Now we can see the precision recall and FN score of both the classes have higher matrix value and an overall accuracy of 98%, and ROC AUC score is also 99%, which is showing the perfect discrimination among the rare classes. So this was the best model we trained, we can say. We also performed hypertuning on hyperparameter tuning on unsupervised models as well, but there was no change in the accuracy because the main issue was class imbalance there. Now we can see the model is ready for deployment because it has 99% of accuracy. When we plot the curves, around 60 epochs, the accuracy is increased, and the validation and accuracy and the training accuracy both have encountered the same value, we can say. They're nearly equal, and the loss has increased lesser than 0.5. The next part is we're saving the best model here, that is the neural network model, as a Keras model and also a pickle model, PKL model, because for cross platforms, PKL will be supporting. Using joblib, we save it, and we're also saving the scalar values for like future deployment. And in case we need, we can download it from files.download of google.collab import. So overall insight is from hypothesis testing, it confirmed that multimorbid patients have higher claims, that is higher cost, and they take more medications, and there is some gender disparities as well. And the person correlation tells that there is a linear relationship between condition and medication. As the condition increase, the medications also increase, or vice versa, we can say. Initial supervised models had an accuracy greater, but they failed to detect the multimorbid patients because of the imbalance we had. So later, computing the class weights and building the neural network, also we got a lower accuracy account around 65 to 70% due to the class imbalance, and for which we generated synthetic samples using CTGAN model on the minority data, the rare class, which is multimorbid. And then when built the neural network, we achieved an accuracy around 98%, and ROC AUC, the discrimination we had was 99%. So the loss and accuracy were also improved. So this tells this the model is ready for deployment, which gives clinically actionable risk predictions of multimorbidity. That was my part. Deployment will be done by Ishan.
Good evening, ma'am, and good evening, all.
Yeah.
So, so the goal of deployment part was to make a model accessible and usable. So we achieved this by deploying it as a Streamlit web application. So first we export the model, we saved the best neural network uh, and its pre-processing scalar as .pkl files using joblib. This allows us to load them later without retraining. After this next setup, we install all the required libraries like Streamlit for the web app, Pangrok for creating a secure public link, TensorFlow and Scikit-learn for the ML model, and Plotly for interactive visualization. After three, we upload model files by Shannon model joblib.pkl and scalar.pkl so that our app could use them for prediction. After that, in the next UI web app design, this section forms the heart of our deployment where we design the user interface and logic in app.py. So first we import the or import and configuration. We start by importing required libraries, Streamlit, Pandas, NumPy, TensorFlow, Keras model, and Droplet broadly graph. Then we set page properties. In page properties, this defines the app title, icon, and layout. After that, custom banner and design. We use HTML and CSS within Streamlit to create a banner. So this gives the app a professional medical dashboard look. After that, load model and scalar. We load the save model and preprocessing files. This ensures a web app uses the exact train model for real-time predictions. Next is input section. We created sidebar widgets for user input. It gives user can easily enter patient details here. After that, in prediction logic, when the predict race button is clicked, so the system scales the input, runs the model, and predicts multi-morbidity risk. Next is display this prediction display results. We show results in a visually clear way. So we also added a confident gauge using Plotly. It gives a initiative visualization of how confident the model is. After that, we run the web app. Finally, we host the web app Streamlit run app.py and npx the locus tunnel code. This command runs Streamlit and provides a public link so the app can be accessed by anyone. And the uh, purpose and outcome is that the UI web app design transform our model into a practical decision support tool. Clinicians can now simply enter patient details, click a button, and immediately receive a multi-morbidity risk prediction with confidence visualization. It demonstrates the complete machine learning pipeline. So after that, in conclusion, summary, our medicine web app not only predicts mobility with high accuracy, but also presents results in a clean professional dashboard, making predictive analytics accessible to healthcare professionals. So it marks the final stage of our end-to-end project bridging research and real-world application. So the dashboard part will be continued by Fida.
So this is our final dashboard. So it is helpful for healthcare providers, clinicians, or as well individuals so to check their risk of multimorbidity. So this is a single patient prediction. The smoothing factor on the left indicates that it will show the raw probability exactly. If the smoothing factor is higher, around 90%, it shows the probability either 0% or 100%. But to get a probability of exact probability, we need to scale the smoothing factor to around zero point 0.5 and 0.6%. So that is what it says. Now, when we enter the demographics here, age is 43. Total claims is the amount billed by the hospital for per patient, number of conditions the patient has already, and number of medications the patient is taking. Total encounters at the severe hospital visits, like if the patient has got admitted, or in case of severe issue they have visited the hospital, so that are the number of encounters. And the gender and race, we have Asian, white, black, and other. So when predict risk, it will give whether it is a high risk or low risk with the exact probability, and a visual which can be downloaded as well. And the batch prediction, when we upload a CSV file, so it will show the batch prediction as a table, and we can also download it. So that was the deployment part.
Okay. So you are done with the project presentation, right? So I just need to see about the PPT and the report.
Yes, ma'am, sure.
Yes, ma'am. I'm sharing with the PPT, ma'am.
Okay.
Ma'am, is my screen visible?
Yeah, it is visible.
Okay, myself Hasni. Now I will be explaining the overview of our total project. Let's get into the agenda of a project. We have the problem statement and the objectives, tools and tech stack we have used in our project, and the architecture diagram, the workflow of our project, the features overview, and the screenshots, results, and the future scope. At last, we'll be going to the major Q&A part. And the problem statement is that in
Hasini,
the
can you
healthcare.
speak a bit up, please? Because somehow your voice is not coming to me properly.
Now is it audible, ma'am?
Yeah, it is audible.
Okay, ma'am. Now we'll be considering the problem statement. In the healthcare domain, the major professionals will be facing the challenges in identifying the patient who will be having more than two medical conditions, which is called as the multimorbidity. In the traditional systems, mostly they depend on the manual diagnosis like the X-rays, CT scans, and etc., which often lead to the delayed intervention. So there is a need of a predictive system which immediately assesses the patient risk using the data-driven insights and even maintains the privacy and the scalability. Next is the objectives we have. The primary objective is that we have developed the machine learning based predictive system to calculate
Sorry to
the
interrupt,
patient.
Hasini. Your screen is stuck. Is
I'll
it stuck
stop
for all of you?
sharing.
I can see her
Yes, yes, it
screen, but
is. It is so.
it is in the first page only. I
Yeah,
thought she is
only
just
the first
explaining the.
slide.
Yeah.
I actually moved two slides further. One second, ma'am. I'll reshare the screen. Ma'am, now is it visible?
Yeah, it is visible.
Okay, ma'am.
You can
Should
start
I
off with
continue?
the agenda. Yeah, you can continue. You don't have to put it all together. You can continue from the where you stopped. Actually, you have started, you are in the agenda section, right? Or the objective one.
Yes, ma'am.
Okay,
Objectives.
you can just start it from there because I thought you were explaining from the same slide, so I didn't interrupt. You can go ahead with the objective section, not an issue.
Okay, ma'am, sure. So let's continue with the objectives. We have considered the primary objective and the secondary objective over here. The primary objective is that
Hasini,
we'll,
sorry to interrupt. Have you just changed the slide? Is it like that?
yes,
Because I am
ma'am.
not getting to see the slide. I can only see the very first page that you have taken into consideration.
Let me share, Hasini. You go with the presentation.
Yeah, okay, sure.
Is that visible now?
Yeah, yes,
Yeah,
Fida.
it is visible.
Objective?
Yes, yes.
Okay.
Can you use the slideshow? Yeah, the primary objective is that we'll be developing a machine learning predictive based system which correctly predicts the patient risk based who are having the more than two medical conditions using the health data and the demographic data of a patient. And the secondary objective we have considered is pre-processing the healthcare data which we have considered from the patient and performing dimensionality reduction and analysis over there and utilizing the CT-GAN model to generate the synthetic patient data and addressing the data scarcity and the privacy of a patient. And we'll be offering both in the single patient analysis mode and the batch prediction mode and visualizing the risk probability in the case of user-friendly dashboard interface and with the color coding indicators also. Let's move on to the next slide. Yeah, this is the tools and tech stack we have followed. Firstly is the programming language. We have considered Python as the programming language. The libraries and the frameworks we have used are Pandas, NumPy, Scikit-learn, Streamlit, Matplotlib, and Seaborn. The pandas, we have used it for the data manipulation, cleaning, and organizing the patient datasets here. And NumPy is for the numerical operations performed on the dataset. And Scikit-learn is for building the model, evaluating and performing feature engineering and calculating the performance metrics in the data. And Matplotlib and Seaborn are used for the data visualizations which are interactive to the user also. And Streamlit is for deploying the model, building and deploying the dashboard with an user interface. Next is the synthetic data generation. For generating the synthetic data, we have used the neural network, which is the CT-GAN technique, which is conditional tabular generative adversarial networks. And the modeling techniques are supervised and unsupervised learning models. Under supervised, we have used the logistic regression, random forest, and the XGBoost. And coming to unsupervised technique, we have used the K-means and the PCA technique. And next is the data handling. We have performed handling data on the with the help of uploading CSV files and performed the pre-processing on that. And deployment is the Streamlit dashboard and version control is GitHub. Next is the architecture diagram. Firstly, we have collected the data over here, which is gathering the health and demographic data from the patient. And next is the pre-processing, where we'll be cleaning the data, handling missing values, and performing EDA on that, which detect the hidden patterns and clusters within the data set. Next, we have considered performing a principal component analysis where we'll be reducing the data dimensions while keeping the necessary key features within the data. And next is the unsupervised modeling, which is performing choosing the best performing model and detecting the hidden patterns and clusters in the data set. Next is the model selection, where we'll be choosing the best performing model, which will be predicting multi-morbidity of a patient. And next, even coming back again for the outlier detection. Outlier detection is performing PCA, which is principal component analysis, for improved performance and the insights. And outlier detection is for identifying the anomalies and the outliers which are within the data set and validating using the hypothesis testing over there. And will be performing training the predictive models for the risk estimation. And using the CT-GAN, will be creating the synthetic data, which will be creating the balance in classes and ensuring the privacy through that. And at last, we'll be deploying the model using the Streamlit UI interface, which will be getting a correct accuracy and deploying that model through the dashboard for real-time patient risk prediction. And next are the features overview. The main features are there, which are a single patient prediction mode, where we'll be allowing a prediction of individual multi-morbidity risk. And second is the batch processing mode, where we'll be uploading the CSV files of a patient more than up to 200 MB of CSV files of multiple patients and assessing them on the batch processing mode. Next is the risk visualization, where we'll be visualizing the risk of a patient through probability score around 0 to 100% and color coding the risk categories yellow, green, and red, which are low, medium, and high categories, and progressive visual indicators in the semicircle format. And dual mode dashboard is combining both the individual and the population level analysis. And model interpretability is which displays the key risk factors which influence the prediction in the demographic format. And next is the user friendly interface. At last we'll be getting a clean, intuitive user interface designed for healthcare professionals most basically. Next is the screenshots. As you have seen earlier in the dashboard, these are the single patient prediction results. And next we have the batch prediction results. Like this, we'll be getting the batch predictions. Next is the results. Uh, we have achieved the accurate and interpretable multimorbidity risk prediction for both the individuals and populations. Next, we have the real-time clinical support to the healthcare professionals. Next is the data diversity is enhanced and privacy is enhanced as we have used the CT-GAN technique for synthetic data generation, which are realistic data. And next is the supportive, proactive healthcare management through early detection of a patient. And we'll be delivering it in a scalable architecture mode in multiple clinical environments. Next, we have the future scope. So in future, we can integrate the real-time patient monitoring through the wearable devices like the smartwatch. And next, we can incorporate them using the deep learning models like the transformers or LSTM for the data analytics. And next, we can implement explainable AI for greater clinical transparency also. We can extend the model through predicting disease progression, like up to which extent the disease has been progressed in a patient, and we'll be calculating the comorbidity patterns over there. And next, enabling the EHR system integration for automated data ingestion and supporting the mobile accessibility for on-the-go risk evaluation of a patient. Next, we have the Q&A section over here. We have collected the major points of the project, which is the main motivation behind our project. As the number of patients having multiple chronic conditions, which are rapidly rising in today's healthcare sector, early detection as proactive management are increasingly needed for a patient, which empowers the healthcare professionals to effectively predict the multimorbidity risk. And second is the machine learning models we experimented with is the supervised models and the unsupervised models. And next is the neural network we have used. And how does your dashboard assist the doctors? It will be delivering the real-time risk scores in the form of a probability score, and using the visual indicators, the doctors can analyze easily and spot the high risk patients and implement the necessary medications the patients require. And we have used the CT scan, make it possible to generate the realistic synthetic patient data, which resolve the privacy issues, and even they are realistic also. And the challenges we have faced is the main as the patient data is huge, around 11 CSV files, we have managing in missing values, and we have more than imbalanced classes in the data sets like the features, and even ensure the model interpretability in a medical context. And this is all about our project overview. Thank you.
Okay, Hasini, just show me the report, and you don't have to go in deep about it. Just show me the details and explain the major things. You don't have to go in really very details because other two sections like the project and the PPT went very detailed oriented. So project you don't have to go a bit in a very detailed manner. You can just show me the overview.
Is my screen is visible?
Yeah, your screen is visible.
I'm going to present our internship project titled Medicine Predictive Analytics for Synthetic Patient Data. It means using AI and machine learning to make predictions about patient health using synthetic medical data instead of real patient records. Our cover page includes the project title, our team members' names, and the company name. Next, we have the certificate page and acknowledgement and declaration. The abstract gives a short summary of our project. It explains that our project focuses on using predictive analytics with synthetic patient data to improve healthcare predictions while protecting patient privacy. Now, moving on to the main part of our project, let's begin with the introduction. Predictive analytics help doctors predict diseases, treatment outcomes, and patient risk early. But real medical data is hard to get because of privacy and confidentiality. So we use synthetic data which artificially generated but has the same patterns as real data. Next, the main problem we identified is that predictive models in healthcare need a lot of high quality data, but real patient data is difficult to use due to privacy laws and limited availability. The main objective of our project is to explore how predictive analytics can work effectively on synthetic patient data. Our specific goals are to study challenges of using real healthcare data and to generate realistic synthetic data using CT GAN, to apply predictive models for disease, to evaluate the accuracy and reliability of these models. By achieving this, we aim to make healthcare analytics both secure and useful. Next, literature review. Many previous studies have focused on using machine learning in healthcare, but they all faced data privacy problems. Older models could not handle complex healthcare data. CTGAN and STB improved synthetic data quality. These models are now widely used for generating realistic patient data without privacy risk. Next, system architecture. This diagram represents the overall system architecture of our project. It shows how data flow from collection to prediction. The system includes steps like data ingestion and cleaning, exploratory data analysis, synthetic data generation, machine learning model training, and evaluation and deployment via Streamlit. Next, tools and technologies used Python, Pandas, and NumPy for data handling, scikit-learn, CTGAN, STV for modeling and synthetic data, and Streamlit for deployment, Google Colab for coding and testing. Next will be continued by Manthan.
Ma'am, is it visible?
Yeah, it is visible.
Yeah, our project consists of majorly 8 modules, which are data collection, pre-processing and EDA, outlier detection, hypothesis testing, dimensionality, reduction, model training, synthetic data generation, and deployment as such. And database design consists of patient table, conditions table, vitals and pre-processed data table, and model result table. And in front end, one minute, ma'am. In front end, we can upload a patient data, view pre-processing results like data summaries and visualization, get real-time data risk predictions, see performance charts like ROC curves and confusion matrix, and download reports in PDF or CSV format. And in the backend, we use Python as the main language and use Streamlit for backend for running logic and serving UI. We have used scikit-learn, ctgan, and XGBoost for model building and data generation. And for the implementation part, developed and tested in Python and Streamlit, used ngrok to host and share app online. Ctgan generated synthetic samples for testing, added security, authentication, and logging for privacy. And the test cases and results are here. We have showcased here 7 tests and test cases like security and secret tests, performance and reliability, model evaluation test, usability and UI test. It performed well, and all parts are tested. The latency gives us 300 microseconds, and the deployment process here. We have saved the trained model in PKL format and created backend using Streamlit and connected to CTCAN to generate data, deploy using ngrok, and test using input files or real-time predictions. And our projects have some limitations. Uh, Data quality dependence. CTCAN depends on input data quality, and it is hard to preserve complex health relationships, and no formal privacy is provided here because we are using synthetic data, may not generalize perfectly to real hospitals, and GAN models need more computing power also. And in the future enhancement, we can add differential privacy for stronger security, and we can use advanced models like diffusion or VAEs for handling long-term patient data. Uh, we can scale up our model by using cloud deployment and develop fairness checks to avoid bias. Finally, in the conclusion part, our project shows how CTGAN can create realistic and private patient data. Predictive analytics on this data can help in disease prediction and decision making. It ensures privacy, scalability, and innovation in healthcare AI. With improvements, this can become a real world clinical support. Thank you.
Okay, you can just stop your screen sharing. Okay, just a minute, group two. I'll just come back to you. So, group one, Aditi, you're here.
Yes, ma'am.
Anyone? Okay, so can you just inform the two members from your team who have not, like as of now, not uploaded the details in the GitHub, like the project details, also the project related to that in the mail ID. Please inform them so that they can do it by today. So tomorrow I'll be checking Aryan and Lakshya from your team. Okay,
Yes, ma'am.
so
Yes,
make
ma'am.
sure that
Informed
you
already. They
inform.
are working on it. They will do the
Okay,
work
fine,
till
not an
tomorrow.
issue. It's Fine, yeah. Tomorrow I need to check it and I need to confirm that your group has already done, because of this two people I cannot confirm that your group has totally like done all of the tasks properly, right? So that is the
Yes,
major
ma'am.
issue. Okay, so
Yeah,
make
ma'am.
sure that they complete it by tomorrow. Fine. And
Yes, ma'am. Sure.
you also have done the Streamlit application, like you have used the deployment in the Streamlit, right?
Yes, ma'am.
Okay. So whenever you people are sharing the GitHub repository link, that one I will be confirming for everyone that you people, for every member have to just do it or not. But I guess every member of your group do have to just take down the GitHub repository for each member of you. Have to upload the same project in the GitHub. Fine. And sharing part I will
Okay,
confirm,
ma'am.
or if not today, by tomorrow. Fine.
Yeah, ma'am. Tomorrow will
And
shortly. Yeah, yeah.
okay. And just take down the screenshot of the project, like the deployment part, that is the front end part, that is website that you have created on. Just take down the screenshot of it as an output and just paste it, like when you are uploading it in GitHub as an output, just paste it down there. Fine.
Yeah, ma'am. I have done the can I show you once?
Okay. Yeah, you can show.
Means I have done the separate visuals part for everything. In visuals I have mentioned the outputs we have in our project. So here it goes like visuals, data, models, and report. And here is the collab file, readme file, app.py file, requirements and shopping trends, the data set we have been used. In
Okay.
visuals, I have all mentioned, all the graphs mentioned, the box plots, whatever the graphs we find it
Okay.
very
Okay.
interactive, I have mentioned it all.
Fine. And also the Streamlit web application, that screenshot, have you just taken into consideration there?
Currently, I have just not take it. I will just take it within
You
one
can
hour
just
and I
take
will
it
just
and
upload it.
attach.
Yeah, ma'am. Yeah, ma'am. Yeah.
It's not, you can take your time. By tomorrow, you can update me. That would be fine. Fine.
Yes, ma'am. Yes. Yes.
Okay. Okay, fine. So,
Excuse me,
apart
ma'am.
from group two, yeah, just a minute, Vida, just a minute, please. Yeah, apart from group two, rest all of you can just exit the session if needed, because I need to just consider the details from group two. Fine. Yeah, Fida, what is the issue? You can tell me now.
Ma'am, we have prepared a EDA visualization report, which Isha was about to
Okay,
present. Is that okay if she presents or not?
okay. Yeah, fine. You can present it, not an issue.
Okay. Isha, please go ahead.
Okay, ma'am. Thank you.
Okay, actually, I thought your presentation is over because it was related to that, then the report. So report part was over, so I thought it is done. Yeah, you can continue, Isha.
Yes, sir. This is a visual report of EDA. So, the project we have already prepared medicine predict analysis for synthetic patient data. So the focus of our EDA analysis is to understand patient demographics, age, gender, race, ethnicity, and detect data quality issues like missing values and outliers. Also analyze disease prevalence, healthcare costs, and medical patterns, and identify key relationships and correlation divine multimobility. In key analysis and insights, there is a feature distribution analysis before versus after outlier handling. After removing outlier, the feature distribution became more stable and balanced. This indicates improved data quality and reliability for model training. And then the visualization of missing value in the data set. A heat map displays where the data is missing in the that trait is mm, data is missing, more data is missing. After that, bright areas represent missing values. After that, in three, patient demographics, birth year distribution. Reveal the most common age groups and unrepresented years. After that, age distribution, patient range from 0 to 100 years, concentrated mainly between 40 to 70 years, ideal for studying age-related healthcare patterns. In the distribution uh, of patients by gender, nearly equal male 0 and female as 1. Representation ensures gender fairness and reduce bias. Next is a distribution of patients by race. One race dominates while others are unrepresented. So this potential bias might need synthetic data balancing. After the breakdown of patient by ethnicity and gender, so in identify demographic groups, example ethnicity of females with higher multimorbidity risk. Next is top 10 most common conditions. Respiratory issues like viral sinuses, pharyngitis, and bronchitis are most common, like this. So, suggest focal area of healthcare resource allocation. Next is claim cost distribution. Median claim is to 1,200 and in interquartile range 400 to 1,800. Outer indicate high cost uh, patients needed targeted management. Next is the condition per patient. In condition per patient, most patients have 2 to 5 conditions peaking at 3. A small group has 8 plus conditions showing severe multimorbidity. Next is the most common allergies. Mold, animal dander, and house dust might dominate key for allergy risk modules. Next is distribution of medical condition per patient. Average is to 4.8 conditions per patient and indicates moderate disease burden. Next is number of medications per patient. Most take 1 to 2, 3 medication, a small subset uh, at 2. A small subset 8 plus as polypharmacy risk and important for safety checks. Then encounters versus condition. Patients with 2 to 5 conditions have 5 to 15 medical visits on average. Extremely high visit counts, more than 25, may relate to chronic or acute cases. After that, claim versus age. Older patients 60 plus have higher healthcare costs. Gender difference are minimal, age is the key cost driver. Next is age versus condition. Older patients tend to have more conditions, confirming aging as a risk factor. After that, gender versus claims. Both gender have similar median cost, but male show greater uh, cost visibility. After that, average condition by race. In this, two races show higher mean conditions, like 5.2, indicating racial health disparities. And then conditional versus medications. Older patient has larger bubbles, show more disease and more medication confirming polypharmacy age correlation. Correlation and pattern correlation heat map. In this heat map, encounter and procedure show almost perfect correlation, 0.99 indicating redundancy. Age inversely correlates with encounters and claims older patients have fewer but costlier visits. After that, parallel categories condition match the encounter and claims. In this, patient with many encounters, medications, and high claims for a subgroup that drives healthcare cost and complexity. In 2D PCA projection of project patients, patients visualized in 2D using PCA show separation between multimobile and non-multimobile groups with some overlap. After that, came in clustering visualization on PCA projection. Clusters show a distinct patient group with similar health pattern and risk profiles, useful for personalized care strategies and risk-based segmentation. So the overall conclusion is that the EDA provides a comprehensive understanding of synthetic patient data, balanced gender representation but imbalanced race distribution. Age and number of conditions are the strongest drivers of multimorbidity, and the respiratory disease dominate cause and visit frequency increase with the disease count. After that, a cluster analysis highlight subgroup for targeted healthcare management. This is the analysis of EDM. Thank you.
Okay,
Can I
got
stop
it.
sharing them?
Yeah, yeah, definitely. So, guys, so you're done with the presentation, right? So, I'll just
Yes.
call out one by one your name. You just show me, you just tell me the details, like all the five projects have you just taken and like presented in the session or not. Next, you need to show me the GitHub repository of yours and the mail that you have shared to the mini project, showing that all of the projects you have just shared in the mail. Okay, okay,
Yes,
clear?
ma'am.
Okay, ma'am.
So just a moment, let me just call out your names. First, Fida. Fida, just show me the GitHub and the mail.
Yes, ma'am. Like I've presented all week project here in the session itself.
Yeah,
So these are the repositories I have. Unemployment rate analysis was the first week project, and the
okay.
diabetes risk analysis second week,
Mm-hmm.
music preferences third week project, and fraud analytics fourth, pneumonia screening fifth week, and this is the major project.
Okay,
Do you want me
fine.
to
Got it.
open them, ma'am?
No, no, you don't have to. You can just share me
Okay.
the
And
mail.
I've not yet shared.
Yeah,
Yeah,
I'm
I've not
asking.
yet shared the sixth week.
Yeah,
I've
that is
shared the
fine.
GitHub
I am
link.
asking about till the fifth week. You can
Yeah.
just go back and where all of the details has been mentioned, just go back. Yeah, that's fine. So here all the five projects, 5 week projects you have shared, right?
Yes, ma'am.
Okay, okay, Fida. You can just stop sharing the screen. Next is Hasini. Hasini, can you just show me?
Yes, ma'am. Ma'am, this is the repositories. Week one
Just
project
a
is
moment.
bank loan approval.
Okay. So all of the five projects I can see, it's fine, Hasini. So you
Yes,
can
ma'am.
just show me the mail once again, like where you have shared.
Yes, ma'am. I have added them in the one link itself, like one mail itself, ma'am.
Okay, okay, fine.
Week one
And
and
I
two, I
just want
didn't. Uh,
week one
yes,
and
ma'am.
two.
Week one and two, I didn't present in the session, ma'am. I have the video, like I recorded. I will mail it
Okay,
like after the class. I'll make it done.
okay. Then make sure that you mail the video link with the details within the mail ID once again with the week one repository details and stuff. Accordingly, you can just mail the video presentation link of week one and week two. Fine.
Okay, ma'am.
Okay, got it. So, next is Isha. Isha, you're here.
Yes, ma'am.
Can you just show me?
Yes, ma'am. This is the GitHub project 1, project 2, and project 3, project 4, and project 5.
Okay.
And in mail.
And the mail?
And ma'am, I've sent 3 of projects. The rest of 2 projects I've submitted on the Google form.
No, you have to see, you have to submit all of the project details, like the project files along with the GitHub link and the video presentation recordings.
Okay, ma'am. I will.
You have to share. You have
Okay,
to
ma'am.
share. So you do one thing, you take your time, but complete it by tomorrow. Fine?
Okay, ma'am. Okay. Thank you.
Okay. Next is Nishchita. Nishchita, you're here?
Yes, ma'am.
Yeah, can you just show me?
Ma'am, this is my GitHub repository. First
Sorry,
week
it's not
project.
visible. Okay, okay, I got it. Yeah. Yeah,
First
tell,
week pro
continue, please.
First week project about Olympic medal count by country, and second week about diabetes risk analysis, and this is third week project, and the fourth week project is about smart city sensor, and the fifth week project predict student performance.
Okay. So all five you have uploaded, right?
Yes, ma'am.
Okay. And show me the mail ones.
Ma'am, this is first week project link, and this is
See, I can only see your GitHub repository, not the mail. I guess you have not shared the entire screen.
now it's visible.
No, not yet. Yeah, now it is visible.
This is first week project. Next,
Okay.
this is a record video, ma'am. This is presentation record video. I upload in email.
O- Okay.
Next, this is second week project, and the second week project video. This, and this is third week project. Third week project video. Fourth week project. This is video, and this is fifth, and this is fifth week project video.
Okay, fine. So you have already shared the video presentation along with the project to the mail, right?
Yes, ma'am.
All the five, right?
Yes, ma'am.
Okay, okay, Nishita. Next is Manthan. Manthan, can you just share me the details once from your end?
Okay, ma'am. This is my GitHub repository, ma'am. The first week project is
Yeah,
about
I can't see. I can't see Manthan. I can't see. Yeah, now it's fine. I can see. Yeah.
the first week project is about global trade repository, and second week is about forex exchange. This is third week, this is fourth week, and this is fifth week, ma'am.
Okay. Okay. Great. And the mail?
Ma'am, these are my project files, and I have
Okay.
presented the first week presentation in the session itself, and other four s-
Okay.
other four sessions are I have
You have recorded.
recording, ma'am. Yeah,
Okay. So
for
you
all
have
four.
shared the recording as well in the mail,
Yes, ma'am.
right?
Yeah, ma'am.
Okay. Fine. Great. Okay, guys. Okay. Fine, Manthan. You can just stop your screen sharing. Okay, thanks, group two. So I just forgot to mention that it was a very good presentation from all of you. Great team effort, guys, and the project was really good from your end. You have prepared a very good project from your end. Thank you, guys, for for sharing me the details. So I'll just
Thank
go
you,
ahead with
ma'am.
that. I'll just go ahead with that, and I just need all of yours name along with the mail IDs. So anyone from your team, just in the chat, just give me all of your names along with your mail IDs, proper mail IDs. So from your group, only Isha is left with the sending the details in the mail, right, Isha? So complete it by tomorrow, okay?
Okay, ma'am.
Yeah. So, guys, as of now, just share me your name along with the mail ID, proper mail ID.
Yes, ma'am.
Excuse me, ma'am.
Yes.
Ma'am, as for the internship certificate request form and the project feedback form, where do we have to submit that? To the HR
Uh,
itself?
I didn't get you. Can you come again?
Like we've prepared a internship certificate request form and a
Okay.
feedback form for our project. So where do we need
Okay.
to submit
Okay.
that?
Okay. Maybe to the HR itself, but I'll just confirm that once and I'll just update you. So, if possible, you can just drop this mail to an HR that these are the forms we are having and where to submit it. Hopefully, they'll give you a proper reply on that. Fine.
All right, ma'am. Thank you.
Yeah.
Okay, ma'am. Uh,
Yeah.
I'm audible. Ma'am, I'm Dikshant from Group 4. Uh, we
Okay.
have a request. We were hoping we could present today, but the earlier team took their assured time. Can we do present first
Yeah.
tomorrow? Like we won't be able to. Most of the team members won't be able to present after day tomorrow. So can we start
Fine.
tomorrow?
Okay. Fine. Okay. So tomorrow you can start off. Okay.
Thank you, ma'am.
Okay. Fine. So you're group four, right, Dikshant?
Yes, ma'am.
Okay. Just make sure that you remind me tomorrow because since we are going in a flow, I might call group three, but just make sure that you remind me in the very first thing of in the session. Okay, so that we can continue with you people.
Sure, ma'am. Sure,
Okay. Okay.
sure, ma'am.
Yeah. So group two, just make it in a same message that everyone's name should be there along with the mail ID. Don't text separately. Just don't drop the chat in the chat. Don't present it separately. Make it in a single
Y-
text.
Yes, ma'am. We are doing that.
There are four people, guys. You have five, right? Okay, Manthan, he has already shared. Fine. Okay. Okay, guys. Thank you so much. I'll just copy that down and we'll go accordingly. So, thank you, guys. You can just leave the session.
Thank
Thank
you,
you,
ma'am.
ma'am.
We'll meet tomorrow, and accordingly, the presentation session will go ahead. Thank you. Bye bye.
Bye, ma'am.
Bye, ma'am.
Bye, ma'am.
Yeah, bye bye.